Tonight's homework assignment is worksheet 5.5b that you were given in class, and today we were really focusing on identifying the domain and range of the graph of a function. So we said the domain of a function really is all of the x values that our graph touches. So the domain then is how far left and how far right the graph reaches. Well, on number 1 it looks like the farthest most point to the left is -3, -3, and the farthest most point to the right is +1, +4. So the domain really stretches all the way from -3 over to +1. So the leftmost point is -3, the rightmost point is +1. So the domain then would be between -3 and -1, and it also includes -3 and -3 and +1, and it also includes -3 and +1. So we would write it like this: -3 is less than or equal to x is less than or equal to 1. Everything from -3 to +1. Then when we're talking about the range, well, the range is how is where the y's touch on the graph, or which y values are reached on the graph. So we want to consider how far down on the graph or how far down on the coordinate plane the graph reaches to how high on the graph our function reaches. So the lowest point on the graph is the same point that we said was the leftmost point, -3, -3. So the y value there is -3, and the highest point on the graph is this one, and the y value of this point is +4. So the domain reaches from -3 to +4, so we would write that as the range -3 is less than or equal to y is less than or equal to 4. On number 2, we haven't seen one exactly like this in class, but again, just like in class today, we need to consider when talking about the domain how far left and how far right our graph reaches. Well, the farthest point to the left is this one, so we need to know the coordinates of that point. Well, that's -1, 2, 3, 4, 5, +3. So -5, +3. And our rightmost point is this one. The coordinates of that point is 1, 2, 3, 4, 5, -2. 5, -2. So our domain values, the smallest domain value is -5, and our greatest domain value is +5. So we would write that as -5 is less than or equal to x is less than or equal to 5. Our range values talks about the highest point and the lowest point and everything between when we're looking at this graph. Well, the highest point is this point. Our lowest point is this point. The coordinates of this point we know are going to be -1, -2, -3, +1, +2, +3, +4. So -3, 4. Our lowest point on this graph is going to be +1, 2, 3, -1, 2, 3, 4. So 3, -4. So the y values then are going to span all the way from -4, which is the bottom point, all the way up to +4, the highest point. So we would write that as -4 is less than or equal to y is less than or equal to +4. And then we'll look at one more on number 3. On number 3, we want to see the farthest point on the graph to the left, which would be this one. The coordinates of that point are -1, 2, 3, -1, 2, 3. So -3, -3. The coordinates of the point that is farthest to the right is over here. So everything in between is included as well, but the coordinates of this point are going to be +3, -3. So our x's go all the way from -3 over to +3. So we would write that as -3 is less than or equal to x is less than or equal to +3. Same thing with the y's. We see that the highest point on the graph, the highest point is going to be this one, and the coordinates of that point are going to be 0, 4. The lowest point would either be this one or this one, but we see that the y coordinates of those 2 points are the same, so it doesn't really matter which one we consider as the lowest. So the range then is going to go all the way from -3 up to +4. So we would write that as -3 is less than or equal to x is less than or equal to 4. So numbers 1 all the way over to 12 are similar to those. So just consider what is the farthest point to the left, what is the farthest point to the right, what is the farthest point up, what is the farthest point down when we're considering the domain and the range. On numbers 13 through 21, we are evaluating a function, and on these numbers 13 to 17, it tells us the domain is -2, 0, and 2. Well, we know that the domain means that the x's are going to be -2, 0, and 2. So on each of these, we need to take out the x and substitute in each of the domain members. So instead of 2 times x, we need to do 2 times -2 and get -4. Instead of 2 times x, we need to do 2 times 0 and get 0, and we need to do 2 times 2 and get +4. We do want to write our range in set form, which is going to look like this, and we're just going to write all of those in there, -4, 0, and 4. We need to remember, though, that if we get any repeating terms inside our domain or range, we want to only list those one time. And then we'll do one more. Let's look at number 16. On number 16, it says f of x equals the absolute value of x. So we're going to take each of these x values and put it in place of x. So the absolute value of -2 is 2. Then we need to do the absolute value of 0. Absolute value of 0 is 0. Then we need to do the absolute value of +2. Absolute value of 2 is 2. When we write that as a set, we're only going to include the 2 one time, even though it appears twice. So we would write that just as 0, 2. On numbers 18 down to 21, the directions say for each function below the range is 0, 4, and 9. So we need to see that the range, that's the y's, are 0, 4, and 9. Find the domain for each function. So now instead of taking out the x and putting in these 3 different numbers, now we need to take out the y and put in these 3 different numbers. Well, we don't have a y in any of these. We see f of x. We said yesterday, when we see f of x, we can really just think of that as a different way of writing y. So in number 18, instead of f of x equals x plus 2, we can think y equals x plus 2. So on number 18, first we're going to substitute in 0 for y. So 0 equals x plus 2. Then we need to solve that equation. Subtract 2 from both sides. The 2's cancel, and we get x on the right. On the left, we get -2. Then we need to do the same thing for 4. Instead of y equals x plus 2, now we need to say 4 equals x plus 2. Subtract 2 from the left and the right. The x's cancel, and we get x equals +2. Then we need to do the same thing with 9. So 9 equals x plus 2. Subtract 2 from the left and the right. The 2's cancel, and we get 7 equals x. So x is 7, x is 2, and x is -2. We want to write that as a set. Since none of those repeat, we're going to list all of our x values, -2, +2, +7. And then we'll do one other. Let's look at number 21. Well, on 21, we're going to do the same thing. We're going to take each of the members of the range and substitute it in for y. We can think of f of x. We can think of f of x as y. So we're going to take out y and put in 0. So 0 equals the absolute value of x minus 2. And then we're going to take out y and put in 4. So 4 equals absolute value of x minus 2. Then we're going to put in 9. 9 equals the absolute value of x minus 2. So now we need to solve these 3 absolute value equations to find out what the members of our domain are going to be. Well, we know that if 0 equals x minus 2, then we only need to solve one equation. Because if we set up 2 equations with this, we would get x minus 2 equals 0 and x minus 2 equals -0. There's not a -0, so we just need to solve the equation 0 equals x minus 2. I'll add 2 to the right and to the left. The 2's are going to cancel, and we end up with 2 equals x. Well, on this one, though, now it says the absolute value of x minus 2 equals 4. We really know that x minus 2 could be +4 or -4. So we're going to set up 2 equations. So 4 equals x minus 2, and -4 equals x minus 2. If we solve both equations, we do that by adding 2 to both sides. The 2's cancel, and we get x equals 6. And we would get when we do the same thing to the other equation, x equals negative 2. And then we need to do this one more time. Solve this absolute value equation. 9 equals x minus 2, and negative 9 equals x minus 2. Solve these equations by adding 2 to both sides. The 2's cancel, and we get 11 equals x on the left-hand equation. And when we do the same thing to the right equation, the 2's cancel, and we get negative 7 equals x. So now we get 1, 2, 3, 4, 5 different x values. Again, we're only going to list each x value once. Hopefully we see that none of the x values repeat, though. All of them are different, so let's just put them as a set. I do want to put these from smallest to biggest. We just need to get used to seeing it written like that. So I'm going to write negative 7, negative 2, positive 2, positive 6, and positive 11. So 11 or 5 different numbers for our domain when the range is 0, 4, and 9. Hope this helps.